All right, so we now know ions have a different number of electrons. So we got to dig way back in our memory here and go back to our periodic table. To build these atoms, we have to remember our charges. So you guys probably remember learning +1, +2, we skip the middle, +3, plus or minus 4, -3, -2, -1, and 0. These are our cations and our anions. Remember, if it's a plus, it's a cation, because remember, cats have paws. They're positive. And this means that they want to lose electrons. Negative means they are anions. Remember, we said they're like onions. Onions give you bad breath. It's negative. This means they want to gain electrons. They want to become more negative. They want to surround themselves with negativity. Now, we're doing number 2 on page 14. So we're going to be doing sodium. Now, we did this one a long time ago. We're going to come here. We're going to find sodium, which is Na. Now, according to this periodic table, okay, we know that the atomic number is 11. This means that I have to have 11 protons. So I'm going to move my protons over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? Now, our atomic mass is 23. Now, I'm going to round up here because that's normally what we see. If you use 22, it's not going to be that big of a difference, but I'm going to round up here. So I need to find my number of neutrons. So we take our atomic mass, which is 23, and we're going to subtract 11. This means that I have 12 neutrons. Okay? So I'm going to take 12 of my brown dots, and I'm going to put them in the center. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there we go. And we're still not done because we still haven't added our electrons. We know our atomic number is 11 and protons are equal to electrons for right now. So we're going to start by filling our first ring. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we've got 8 on this ring, and we know once you read 8, that's the octet rule. We stop, we go to the next ring, 11. So what we see is we have this little electron out here all by itself. This is our valence electron. For an isotope, that's a problem. So what we need to do is figure out, well, excuse me, for an ion, stop that. I'm going to back it up. Okay, so ions are not happy with this extra electron out here. This means that they're unstable. They want that magic number of 8. So with an ion, especially an ion of sodium, which we said is Na, okay, we're going to go to our periodic table, and we see the charge of sodium is +1. This means because it's a cation, it wants to lose an electron. And guess which one it wants to lose? The one on the outside shell. So what we're going to do to make this an ion, we're going to take this blue electron away. So now we have this happy ring. Now in theory, this extra electron we pulled away should bond with something else. But we can't show that on this paper. So what we're going to do is we're going to now come back over here and we're going to answer our questions. So we're going to begin to fill this in. We're going to count. We know protons. We said from the periodic table and from our model, we have 11 red dots. We have 12 neutrons because that's how many brown dots we did, and we already calculated from subtracting the atomic mass onto the atomic number. But this time, we are supposed to have, we're supposed to have negative 11 electrons, but we don't. We only have -10 because this charged atom has gotten rid of, hence the Na+1, of its valence electrons. So how many protons does this ion have? 11. Electrons? Well, it's supposed to have 11, but in our model, it has 10. So what is the net charge? Well, what do we have more of? Protons, neutrons, or electrons? Well, we have a lot of neutrons, but neutrons don't have a charge, so that doesn't change anything. But we now have more protons than electrons. Well, we have more positive than negative, so this means we've become more positive. This is why it says +1, because electrons have a negative charge. What is the symbol for this ion? Na+1. This lets us know that it has given away that electron. Now I'm going to do this for one more, just so that you can understand. I'm going to use an anion this time, just to make sure that you understand the difference between atoms, isotopes, and ions. Atoms are of neutral charge. Isotopes have a different atomic mass. They have a different number of neutrons. Ions have a different number of electrons. So I'm going to move my dots back. And I'm going to start over. And we're going to do number 3 on the same page. So we're still dealing with ions. We're still on part 3. We're still on page 14. But this time we're going to do number 3. We're going to do chlorine. So I'm going to come to my periodic table. Now chlorine this time has a charge of -1. So it's an anion. So we're going to model this. This time chlorine has some pretty big numbers. So chlorine has 17 protons and 17 electrons. So we're going to start with our protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Ooh, that's a lot. Okay. Now, we're going to go ahead and find our mass because I want to finish my nucleus first. So we're going to take my 35 and we're going to subtract 17. So we do some math here. You should get 18. So now I'm going to count my neutrons. 1, 2, 3, 4, 5, 6, 7, 8. If they'll all fit. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. They barely fit in my nucleus, but they're there. Okay. So now we're going to build our electrons. We have 11 protons, or excuse me, 17 protons. We should have 17 electrons. So we're going to start with our first ring. 1, 2. That shell's full, so we go to the next one. 3, 4, 5, 6, 7, 8, 9, 10. That shell is full. So we're going to go to our third one. 11, 12, 13, 14, 15, 16, 17. This is what a normal calcium atom looks like. But we're dealing with an ion. This thing has a charge of -1. If it is negative, remember that we're gaining electrons. So this means that we're going to have to add another blue dot because there's only 7 in this outer shell. The octet rule says we want 8. So somehow chlorine has hooked up with something, more than likely sodium, and has gained that wonderful electron. So now we have 8 in our outer shell. So let's put this on our lab sheet. For our lab sheet, we now know chlorine has 17 protons, 18 neutrons, and it's supposed to have 17 electrons. But in our model, it has 18. So how does this change the charge of the ion? Well, how many protons does the ion have? 17. How many electrons? 18. So now what is the charge? Compared to sodium, where we had more protons than electrons, this time we have more electrons than protons. This means we're negatively charged. So we have a negative charge. This is why we write it Cl minus 1. It's because we have gained negativity. We have gained an electron. You'll do the same thing for number 4 and 5 on page 15, and that will be it. So when you're done with this, you should be able to compare and contrast a stable atom on pages 8 through 9. You should be able to compare that to an isotope, which is pages 11 and 12, and then ions on 13 and 14. To help you kind of recap all of this, I have placed a picture of all 3 types of atoms side by side. I hope this helps. I hope you enjoy the lab. If you want to, send me some pictures of how you creatively made your atoms. I chose Play-Doh. If you have any questions, please let me know. Keep learning.